Good morning, everybody. Today we are discussing the next topic of the nuclear chemistry, that is the application of the radioactive isotope. So, radioactive isotope means it is an isotope of the sum of the element which shows the radioactivity. So, radioactive isotope has a relevant role in our daily life. It is used for the various application like C14 dating, and it is used for determining the age of a rock and archaeological sample. And it is also used in the medicinal diagnosis and therapeutical purpose and study of the chemical reaction pathway. These are the major application of the radioactive isotope. Now we are moving into the C13 carbon 13 14 C14 dating or radiocarbon dating. So in the atmosphere, the major component of the atmosphere is the nitrogen, normal nitrogen, CN14. So this nitrogen 14 bombarded with the neutron, it is easily converted into carbon. There are three different type of the carbon isotope are available in the atmosphere. The one is C14, C13 and C12. Among which C14 is radioactive, and there is a very trace amount of the C14 is present in the atmosphere, and this carbon, radioactive carbon, react with the oxygen in the atmosphere and readily converted into carbon dioxide. So similarly, the other isotope of the carbon is also react with oxygen and to form the carbon dioxide. So in the atmospheric carbon dioxide, only the trace amount of the radioactive carbon is also present in the carbon dioxide. This carbon dioxide is absorbed by the plants for the photosynthesis, and they will during the photosynthesis the plant form the carbohydrate, and this carbohydrate containing a trace amount of the radioactive C14. When this plant is eaten by the animal, this radioactive isotope enter into the animal body, and during respiration they will again re-emitted into the they will again entering into the atmosphere. So they are exist in an equilibrium, but when this animal dies, this equilibrium breaks, and the animal, the C14 present in the body of the animal undergo radioactive decay. So carbon 14 undergo beta decay and to form the nitrogen 14, and as the age of the particle increases, the amount of the C14 in the archaeological sample decreases. So we can easily find out the age of this particle by using the equation lambda is equal to 2.303 divided by T into log N0 divided by N, where N is the half-life period of the C14. It is 5716 years, and we can find out the T, and N0 is the C14 of the fresh sample, and N is the radioactivity of the C14 of the archaeological sample. So if we are substituting the value, we can find out the T, that means T half, that means the age of the sample. So thus we can find out the ages of the archaeological sample. So the next application is the rock dating. Rock dating means we can find out the age of the rock by measuring the radioactivity of the uranium isotope. We know that the uranium 238, that is the natural uranium which is present in the atmosphere, present in the nature, but the amount is very less. But this uranium 238 undergo the decay and to form the lead Pb. So as the age of the particle increases, the amount of the lead, stable isotope of the lead, will increase, and the amount of the uranium in the rock particle is decreases. See here, the left hand side is the rock which is in the living sample. It only contained the uranium isotope. But after some years, the uranium converted into lead. Okay, lead is a stable isotope. It will not emit any radioactivity. So, by measuring the amount of the uranium which is decay in the rock particle, we can find out the age of the rock particle by using the above equation. Because we can measure the amount of the uranium which is present in the rock particle at present, and also calculate the amount of the uranium which is present in the rock particle when it is in the earlier stage also. Then we apply the above equation. Lambda is equal to 2.303 divided by T into log N0 divided by N, where N0 is the amount of the uranium which is early present in the rock, and where N is the amount of the uranium which is present now in that rock. So thus we can find out the age of the rock very easily. See here, the first one is the rock particle, that is a live rock particle, and it contains only the uranium nucleus. After 1 billion years, the sum of the uranium is converted into lead, and for 2 billion years there are only few uranium nucleus is present in the rock particle. After 3 billion years, the amount of uranium is very less when compared to the first one. So thus we can measure the amount of the uranium which is present after this much years, and we can also calculate the amount which is initially present in the rock. Then we apply in the previous equation. We can easily find out the ages of the rock. Thank you. So this question is very important, frequently asked as an essay question in university examination. I hope that you understood the concept. Thank you.